Hello and welcome to the instructional video on section 19.8, which is dealing with complex numbers. Our complex number that we're going to deal with is I. I is called the unit imaginary number. That's why it's denoted with I, because it's imaginary. So I is going to denote the square root of -1. This will allow us to take square roots of negative numbers, which before today we could not do. Note that when dealing with complex numbers, the number I, the proper notation is in the form of a plus bi. So we have some examples. First, to get started with, we're going to take some simple negative square roots. So we have here the square root of -21. I'm going to separate that into the square root of -1 and the square root of 21. If we multiply those back together, we get the square root of -21. So we know that the square root of -1 is I, and we cannot simplify the square root of 21, as 21 factors to 7 and 3. Both are prime and not perfect squares. So here, if we look at number 2, I wanted to denote this and separate it out as square root of -1 and the square root of 43. As you notice, I just carried the negative out and left it in front. So we have negative square root -1 times the square root of 43. So we're going to leave that negative out. Square root of -1 is I, and we still have the square root of 43. 43 is a prime number, therefore it is not a square. So let's look at the square root of -128. So once again, we're going to factor out that square root of -1, and then with the number 128, I'll come out here to the side and will, once again, I keep going too quick for my lovely computer. We're going to factor out 128 to see how perfect squares we have in it. And I'm still too fast, so we're going to slow down just a touch. So I have 128. Okay, I know that 2 goes into 128, and it goes into it 64 times. Right there, I can stop. I know 64 is a perfect square. That is 8 squared. So I break up my 128 into the square root of 64 and the square root of 2. Now if I were to multiply these three back together, 2 times 64 is 128, times -1 is -128. So we've just did it, we have not changed the value. Okay, so we know the square root of -1 is I. Okay? We know the square root of 64 is 8. I'm going to put 8 out in front of the I. And the square root of 2 is the square root of 2. We can't simplify that anymore. So my final answer for the square root of -128 is 8i times root 2. So let's do the same thing here with -48a. First thing as I do is I pull out that square root of -1. I'm also going to pull out that square root of a. It's a variable. I like to get that separate. So now we're going to come out to the side like we did with 8. And we are going to factor 48 to see what kind of perfect squares we have into it. Now I could prime factor it, but I know 16 goes into 128, and it goes into it 3 times. So once again, I can stop, because I know that 16 is 4 squared. 3 is prime, can't simplify it anymore. So this is going to become the square root of 16 and the square root of 3. Once again, I multiply these 4 terms back together. 16 times 3 is 48. 48 times a is a. 48a times -1 is -48a. So we have once again have not changed the problem. This is again to get into a good habit of double checking this, to make sure you factored correctly and to catch any mistakes before they happen. So we've done that. Let's simplify. We know the square root of -1 is I, so we write that down. Okay. The square root of a, we're still just going to have a. And the square root of 16 is, and hey, what do you know? Once again, I get a little too fast for my lovely computer in this program, so let's go a little. So we know the square root of 16 is 4, and the square root we cannot do anything with, so we leave it underneath the radical. So the square root of negative 148a turns out to be 4i times root 3a. do a little addition. We already have our i's in there, so we're just going to add. We need to find like terms. So the first thing I'm going to do is identify the like terms. I know that 12 and 6 are like terms. They're just numbers. And then I can get my I. I have 4i and negative 3i. So I'm going to rewrite this. It is an addition problem. I don't need the parentheses, so I'm going to get rid of them and get my like terms together. So I'm going to have, and once again, hey, too quick for my computer. I'm sure you guys are getting tired of hearing that. So am I. So we get 12 plus 6. And then the ones I've in yellow, the I terms, is plus 4i minus 3i. So I need to simplify this. And there's a reason I wrote the I terms second. Because if you remember, they need to be written in the form of a plus bi. So my a's are going to, my numbers are going to be first. 12 plus 6 is 18. And my I terms are second. 4 minus 3 is 1. So it's 18 plus I. Now let's do a subtraction problem. Once again, let's denote our like terms. I have 9 and my 2. I have 4i and my negative 2i. Okay, but here one thing I need to do first is to distribute this negative through the parentheses. Okay, so I'm going to have 9 minus 4i, distribute my negative. So it's going to be in a negative 2 and a positive 2i. Remember to distribute that negative to both of them. I can denote my like terms again. 9 and negative 2. Negative 4, positive 2i, negative 4i, positive 2i. So let's get those together. And get my equal sign correct. So I'm going to have 9 minus 2 and minus 4i plus 2i. Combine those. 9 minus 2 is 7. Negative 4 plus 2, negative 2i. I'm in the form a plus bi. I am good to go. Let's move on. Look at some terms of I. So we know that I is the square root of negative 1. We've established that. We've talked about that. So let's go a little bit further. If we look at I squared, we know that I squared is going to be negative 1. Anytime that you square a radical, you get what's inside. So we square the radical, we get what's left inside. It gets rid of the radical. So negative 1, square root of negative 1 squared is negative 1. So if we look at I to the third, we can break that up. I times I squared. We know that I squared is negative 1, and that I is I, so it becomes negative I. I to the fourth, we can break that up as I squared times I squared, which is negative 1 times negative 1, which is then going to positive 1. From here, it is just going to repeat in factors of 4. So if we go to the square root, or excuse me, if we go to I to the 5th power, we get that up as into I to the 4th, which is 1, and I. So I to the 5th is I. I to the 6th, break into I to the 4th and I squared, so we're at negative 1, because that's what I squared is. I to the 4th, once again, is 1. I to the 3rd, that is our I to the 7th, so I to the 4th times I to the 3rd. I to the 3rd is negative 1, or is negative. I to the 7th is negative I. So we have I to the 8th, that up into I to the 4th times I to the 4th. I to the 4th is 1, 1 times, obviously, 1. And as you can see, it just continues there. So I to the 9th is I to the 10th is negative 1, I to the 11th is negative I to the 12th is 1. So if we continue to go, it's just going to go into factors of 4. I to the 13th is going to be I to the 14th is going to be negative 1, and so on. If you have any issues with that, please raise your hand right now if you're in class, and get a hold of your math coach or your instructor, and maybe they can clear it up a little bit for you. But we're going to move on, and so we're looking at some examples. So we want to multiply here. So I have the square root of negative 4 times the square root of negative 9. So we know that's the square root of negative 1 and the square root of 4 times the square root of negative 1 and the square root of 9. So we know the first one is 2i, the second one is 3i. So So if we multiply those, we're going to get 6i squared. We look up at our little chart up here, see that I squared is negative 1. So that is 6 times negative 1, which is 6. Our second one here is we're just going to distribute this 6i through the parentheses. So I have 6i times 4. I have 6i times the quantity 4 minus 3. So I have 6i times 4 plus 6i times negative 3i. So 6i times 4 is 24i. Negative and a positive would be a negative, so it's going to be a negative 18i squared. Okay. So we know that I squared is 1. So we have 24i minus 18 times negative 1, since I squared is negative 1. So I'm going to have 20, and too fast for my slow computer again, lovely. So I'm going to have 24i plus 18. And remember, I'm not done. I need this to be in the form of a plus bi. So it's going to be 18 plus 24i. No need to factor here, as we want it in the a plus bi form. So that is my final answer. Let's move a couple more multiplying. So here, number 9, we have two quantities we're multiplying together, so we're just going to use the distributive property, or if you want to call it FOIL, you go right ahead. So we're going to take the 6 terms. So I'm going to have 6 times 4 plus 6 times negative 9i. And then I take my 5i to both terms. So I'm going to plus 5i times 4 and plus 5i times negative 9i. So let's simplify this. 6 and 4 is 24. And I've already made a mistake. See how easy it is? 6 and negative 9 is negative 4, and we just bring the I with it. So we have 5i times 4, which is going to be 20i. And our last term, positive negative is a negative, 9 and 5 is 45, I and I is I squared. So we can combine some like terms. So we have like term here, and we will have like terms here and here, because once again we know I squared equals negative 1. So this is negative 45 times negative 1, which is a positive 45. So I can rewrite 24, and hey, too fast for my computer again. Rewrite this as 24 plus 45 and negative 54i plus 20i. Simplify those. 24 and 45 is going to be the number 69. Too fast for my computer. So much fun to keep doing this over and over again. So where were we? 24 plus 45 is 69. Jeez. Let's go slow this time to see if it'll work. There we go. 69. And then negative 54i and positive 20i, negative 34i. We are in the form of a plus bi, so we are finished, and that is our final answer. So here we go with number 10. We have a quantity squared. There's two ways you can do this. I'll show you both ways. The first way, we can expand it. 4 minus 2i times 4 minus 2i. We do that. We get 16 minus 8i minus 8i plus 4i squared. All I did was distribute. First, outer, inner, last. Distributive property, FOIL, whatever you want to call it. So I can rewrite this as 16 minus 8i plus 8i minus 4, because we know, once again, I squared is negative 1, and negative 1 times 4 is negative 4. I have my like terms. You can rewrite it together if you want. I will not. I will just combine them. And I can see I already made a mistake. Let's fix that right quick. I didn't copy down the line. So it's 16 minus 8i minus 8i minus 4. We know that 16 minus 4 is 12. And negative 8i and negative 8i is negative 16i. Once again, we do not need to factor there because we want it in the form of a plus bi, so we are finished. The other way done. Remember, anytime we have a binomial squared, that equals, if it's a minus b squared, that's going to equal a squared minus 2ab plus b squared. So in this term, my a is 4, my b is 2i. So I'll have 4 squared minus 2 times 4 times 2i plus 2i squared squared is 16. 2 times 4 is 8, times 2 is 16. So we get a minus 16i plus 4i squared. So we know that's going to be a minus 4 because I squared is negative 1. So we have 12 minus 16i. Either way works, whatever you are more comfortable with. Let's go to our last set of examples. We're going to rationalize the denominator just like we did in the last section. So we need to multiply by the conjugate. So what's our conjugate? Well, remember, we just changed